Welcome to another tutorial for a complete course in calculus. So we'll look at some examples for one-sided limit, and then I'll show you what the intermediate value theorem is and how to apply the intermediate value theorem, and sometimes how do we find the number C. So first things first, let's start with this one-sided limit. It says find the limit of the rational function 1 over x squared minus 16 as x approaches to 4 from the left. So what I need to do is I'll try to factor the denominator. So this will give me limit of 1 over, this is a difference of two squares, x minus 4, x plus 4, as x approaches to 4 from the left. So one thing I can do is, because you are approaching 4 from the left, the only issue will be this expression x minus 4. So I can bring this guy up here in the numerator. So this will be limit of 1 over x plus 4 divided by x minus 4 as x approaches to 4 from the left. Now in this case, it will be very easy for us to visualize if we are using the numerical method. So now let's see what happens. If x is approaching 4 from the left, 4 from the left means what? Somewhere over here, which is like, think of 3.99, right? Sufficiently close, of course. Now, what happens to the numerator? So the numerator becomes 1 over 3.99 plus 4, which is nothing but close to 8. Okay, so this guy becomes 3.99 minus 4. So if you are wondering why I'm using the numerical method, the answer is, for this particular example, there is no way of simplifying any further. So either I have to graph it, which means I have to use the graphical method, or numerical method. So now what happens to this numerator? This guy becomes 1 over 8, of course 7.99, but it's sufficiently close to 8. So now 3.99 minus 4, this guy is going to be negative 0.001. Now, if I am sufficiently close to 4 from the left, this guy is nothing but very close to 0, but negative. The numerator is very close to 1 over 8. So what does that mean? Now, the numerator is a constant. It's just a number, 1 over 8, close to, 1 over 8. But this guy is getting very small with a negative. So a fixed number divided by a very small number goes to what? Infinity. But I have a minus sign here, so the answer will be what? Negative infinity. So the limit of 1 over x squared minus 16 as x approaches to 4 from the left equal to what? Negative infinity. So what does that mean? What is the geometrical meaning of that? It means x equal to 4, because the limit goes to infinity, negative infinity. X equal to 4 is a vertical asymptote. That's what it means. At x equal to 4, we have a vertical asymptote. So if somebody asks you, does the limit exist? The answer is no, because limit exists means what? It must be a real number. Very good. Let's see another similar example. So a similar example here, it says find the one-sided limit, the limit of 6 plus 1 over x, as x approaches to 0 from the left. So again, I'm going to use the numerical method. I am approaching 0 from the left. From the left means what? Negative 0.001. Any number sufficiently close to 0. So this becomes what? 6 plus 1 over negative 0.000, whatever number. Okay, in this case, I just pick negative 0.001, but it doesn't matter. You pick sufficiently close to 0. Now, the constant 6 is fixed, but what happens to this guy, the second expression? Again, for the same reasoning, 1 numerator is fixed, but the denominator is getting smaller. It's getting smaller means what? A fixed number divided by a small number will go to infinity, and with this a minus sign, it will be negative infinity. But 6 is fixed constant, it's fixed. So 6 plus negative infinity becomes what? Negative infinity. So what that means? The limit of 6 plus 1 over x as x approaches to 0 from the left goes to negative infinity. So the limit does not exist. Again, similarly, the geometrical meaning of this limit goes to negative infinity means x equal to 0. This guy is a vertical asymptote. That is what it means. X equal to 0 is a vertical asymptote. Now let's see one application of continuous function. That's what we call it, the intermediate value theorem. So what is the intermediate value theorem? Intermediate value theorem says, let's say you have a graph, any graph. This is the graph of a function f. Let's say at a, the value is f of a, and at b, the value is f of b. Now the intermediate value theorem says, if this function f is continuous on the interval ab, on the interval ab, this function is continuous. Continuous means what? Literally it means without lifting your pencil. So if it is continuous, and if you pick any number k, where between f of a and f of b, without lose of generality, let's assume that f of a is less than, f of b. If it is the other way, it makes no difference. I mean, it will be f of b is less than or equal to k is less than or equal to f of a. The point here is you have k between f of a and f of b. So the intermediate value theorem says, if it is continuous and k is between f of a and f of b, there is a pre-image, which we call it C. So for this k, there will be a C where in the interval AB, such that f at C will be equal to what? K. So which means for a k, for a number k between f of a and f of b, there will be a pre-image, an x value in the interval AB such that the value of the function at C becomes what? The k. That's what exactly intermediate value theorem says. Now, let's see this example. So you are given f of x to be x squared plus x plus 1. So the first question is this function continuous on the interval 0, 5? The answer is yes, because it is a polynomial function. Polynomial functions are continuous on the entire real number. In particular, it's continuous on 0, 5. Okay, so let's find the value of f at 0. So what is f at 0? You just plug here, 0 squared plus 0 plus 1, which is 1. Now, what is the value of f at 5? So this is 5 squared plus 5 plus 1, which is 25 plus 5 plus 1, which is 31. Now, let's see. So the question is, the value of k is given to be 7. So the value of k is given to be 7. So in our case, the k value is 7. Now, is 7 between these two numbers, between f of a and f of b? The answer is yes. Since f is continuous and 1 is less than 7, the k value, which is less than 31, the conclusion is, by intermediate value theorem, there is C, where? On the interval 0 to 5, such that the value of the function at C equal to 7. That's what the intermediate value theorem tells you, existence only. It doesn't tell you how to find. So if you want to find, then we have to use other algebraic techniques. But that is what intermediate value theorem says. There is a number C, at least one C, between 0 and 5, such that the value of f at C equal to 7. Okay. Now, how do you find C in case, you know, somebody asks you to find what is that C? So the answer is f is defined to be f at x is x squared plus x plus 1. So f at c becomes what? C squared plus c plus 1 equal to 7. Now, in our particular example, in this case, finding C becomes solving this quadratic equation. So you see, if it was any other equation, we may or may not be able to find the value of C. Maybe we need some numerical techniques. Finding C is not that easy. But in our case, it's quadratic equation, which we can solve it. So how do you solve that? So many ways. One is you subtract 7 on both sides. So that would be C squared plus C minus 6 equal to 0. Now I can factor this quadratic expression. So it will be what? C plus 3, C minus 2 equal to 0. So C plus 3 equal to 0, or C minus 2 equal to 0. So the value of C is what? Negative 3, or the value of C is what? 2. Now, remember, I said C must be where? Between 0 and 5. So which number is between 0 and 5? Definitely C equal to 2. So our conclusion will be what? The value of C guaranteed by the intermediate value theorem will be what? C equal to 2. Thank you for watching. See you in the next video.